Hi guys, let's continue with where we left off with trigonometric integration. Okay, so now let's have a look at case 2. Last video we went with case 1 for sine and cosine. This is case 2. Okay, case 2 is going to be when the power of cosine is odd. Okay, so what do? So we have to remember we're gonna split the cosine function. So we're gonna take out one factor of the cosine function, similarly with what we did with when the power of sine is odd. Okay, so let's have a look at an example. Okay, let's say we've given with the question sine to the power of 4x times cosine to the power of 3x dx. Okay, so what we're gonna do is we're gonna split the cosine function here. Why? Because that is the one that was odd, not the sine function. Okay, if we do split it, we're gonna get cosine square of x times cosine of x dx. Okay, now what we're gonna do is the same thing we did with the sine problem in the last video. Again, if you did not watch the last video, please do watch it because that also goes into important stuff about trig integration of sine. What happens when the power of sine is odd? Okay, so the formula we used is cosine square x equals 1 minus sine square of x, and sine square of x equals 1 minus cosine of square x. Okay, these two formulas and also the half angle formulas. If when we do come across, I will write them down, the half angle formulas. Okay, so here we can let cosine square of x, okay, using that formula, we can let that equal, sub in that 1 minus sine square of x times cosine of x dx. We can let u equal to sine of x du equals cosine of x dx, and then either way we could say dx equals, I kind of like to sub in dx instead of subbing in for cosine of x. We could say dx equals du over cosine of x. Okay, so again, sine of x is our u, so u to the fourth 1 minus u squared times cosine of x times, so what our dx is du over cosine of x, right? So we're going to sub in that du over cosine of x, cross both of them out, and we're left with u to our u's. So now we could just do the normal process of integrating. So u to the fourth, we're going to multiply that out, minus u to the second. Okay, so that's going to give us this, and we're going to use the normal power rule for integration. So it's going to be u to the fifth minus over 5 minus u to the seventh over 7. Apologies for the cursor. Is not behaving how it should be. U over 7 plus c. Okay, now we sub that in our u. What was our u? Sine of x to the fifth over 5 minus sine of x, sine x to the seventh over 7 plus c. Do not forget that constant of integration because we're finding an indefinite integral. Now let's see what happens when both the powers of sine and cosine are even. Okay, so sine and cosine are even. So what we would have to do is use the half angle formulas basically. So now I'm gonna write down the half angle formulas if you were not able to note them down. So let's have a look through an example how we are going to use the half angle formula. So say we're given the problems to find the integral of sine square of x times cosine square of x dx. Okay, so both of them are even. So in this case, as I was saying, we're going to use the half angle formulas. So what were the half angle formulas? They were sine square of x equals 1 minus cosine. Pointer, where did he go? Pointer, okay, he's back. Pointer is back. Let's go. 1 minus cosine 2x over 2. Cosine square of x is equal to 1 plus cosine 2x over 2. As I was saying, since cosine and cosine match, that's what that plus sign comes in. Since sine and cosine do not match, sorry, that's why that negative sign comes in for that 1 minus cosine 2x. As an easy way to remember what that why that's when that sign is negative. Okay, so let's sub that in. Okay, so for sine square of x, 1 minus cosine 2x over 2 times 1 plus cosine 2x over 2. So guys, one thing you will generally see in problems is us trying to remove the square. Because then when the square comes in, that's when the problems comes. A power greater than 1 is when we gotta use formulas. We gotta use formulas to somehow reduce them. Okay? So what do we do next? Our next step is to do well, we could take the halves out. Let's take the half. Since we're multiplying these two, we could take the half out of both of them. So if we did take half of this and the half from this, it's going to be 1/4. And then we could bring that out of the integral, and it's just going to be 1 minus cosine 2x times 1 plus cosine 2x. Right, guys? Okay, so what, as we know, using the difference of squares, if you remember, recall the difference of squares, a plus b, I'm going to write down the formula over here, a plus b, a minus b. Okay, if you see something that resembles like that, it's going to be a squared minus b squared. Okay, now we can see over here, this is something that resembles that, right? So we could write down these two right terms as 1 minus 1 square, which is just 1, minus cosine square 2x. Okay, guys. Pointer, buddy, again playing games. So dx, not to forget the dx. My apologies, dx, and dx over here too. Okay, and then 1/4, and then now we're gonna use our sine square formula. If you recall, 1 minus sine square of x equals 1 minus cosine square of x. And do you see something? This looks something like that, but the only difference is that 2x. Okay, so how is this gonna look? It's just gonna look like sine square of x, but instead of x, we're gonna put 2x. Okay, there we go. Now, okay, now what we could do is we could again 1/4. What we could do, the next step is we could write down. We can do a u sub for the 2x. We could say u equals 2x, and then du is going to equal to 2 dx, right? And then not to forget that dx, so dx is going to equal to du over 2. Okay, so I'm just going to du over. I'm going to erase this and simplify this step. Okay, so I'm just going to if dx is going to equal to du over 2, right? So that half, that's going to come out. That's going to come out. Okay, so when that comes out, that's going to be, we're going to multiply 1/4 times 1/2, and it's going to be equal to sine square of u, right? And right? So it's going to be du times du. Okay, okay, so it's going to be 1/8. Now let's try and solve this even further. We know sine square of u, again, we're going to go back a step and we're going to write that down as 1 minus cosine square of, no, let's use the half angle formula here, since, let's use the half angle formula here. It's going to be 1 minus cosine 2u over 2 du. Okay, 1/8, and then we're bringing the half again outside. Now, finally, oops, ad blocker, why ad blocker? Long time ad blocker. Okay, let's go back. So again, we're gonna bring that half again outside, and we're gonna be left with 1 minus cosine of 2u du. And we're gonna be left with 1 over 16. 1 minus cosine 2u. Well, now we're just taking the integral, basically, guys. So what we're gonna be left with, I'm gonna erase this. What we're going to be left with is integral of 1 is u, and then integral of cosine 2u. Remember, integral of a sine is going to be, what do we know the integral of cosine is? It's going to be sine, right? 2u, and then it's going to be the derivative of whatever it's inside. So the derivative of inside is going to be just 2. Okay, so that is our answer, and we're going to, of course, have that plus c. Okay, now we could we're just putting that bracket so that because we haven't multiplied it out yet. So we're gonna plug in back our u. What was our u? U was 2x. Okay, so our final answer is gonna look like 1 over 16, 2x minus sine of 2 times 2x. 2 times 2x is 4x. Okay, sine of 4x over 2 plus c. Okay, we could even simplify this further, or you could either write down this answer, or you could write down x over 8 minus sine 4x over 32 plus sine 4x 32 plus c. Okay, guys, either this answer or this answer works. Okay. Oops. Okay, guys. So in the next video, we will be going with the tan. We will be having a look at what happens when we have powers of tangent, and secant. Okay, guys, and we will finish with that one. The powers. We will have a look at a couple of similar formulas that resemble the ones we've already seen. Okay, and hopefully you will kind of see similarities between the both of the processes, and we will have a look at what happens when we have powers of tangent and secant, guys. If you did like the video, found it informative, please do like, share, and subscribe to the videos, guys. Thank you very much for watching, and I hope you have a great rest of your day. Thank you.